For most of human history, closing something securely required effort. Clothing was tied, buttoned, hooked, or laced. Each method worked, but each demanded attention. Buttons had to be aligned, laces had to be tightened evenly, hooks could slip under stress. These closures relied on the user to finish the job correctly. As daily life accelerated, this dependency became a problem. People dressed quickly, they moved more. Clothing experienced more strain. The failure of a closure wasn't just inconvenient, it was embarrassing, distracting, or even dangerous. The challenge was deceptively simple: create a closure that was fast, repeatable, and strong without relying on careful human input. Early attempts tried to improve existing systems: better buttons, stronger hooks, tighter clasps, but all of them shared the same flaw. They concentrated force at a few points. When stress increased, failure followed. The zipper approached closure differently. Instead of resisting force at isolated points, it distributed force along an entire line. Each tooth carried a small share of the load. No single connection mattered very much, which made the whole system resilient. This is the first realization. The zipper is not a fastener. It's a guided alignment system. The slider is the key. It doesn't pull the teeth together through strength. It positions them so that they interlock naturally. Once engaged, the teeth hold each other in place. The slider's job is done before you even realize it. Design constraints shaped every part. The teeth had to be uniform to avoid jamming, yet flexible enough to bend around the body. They had to resist wear while remaining small. The tape holding them had to be strong but soft. The slider had to work under uneven tension, dirt, and misalignment. Trade-offs were constant. Larger teeth increased strength but reduced comfort. Smaller teeth improved flexibility but risked separation. Metal offered durability. Plastic offered lightness. Each context demanded a different balance, but the core mechanism remained the same. Human behavior guided the final form. People pull zippers quickly, often at an angle. They stop abruptly. They apply uneven force. A zipper had to tolerate misuse without punishing the user. It needed to fail gracefully, not catastrophically. That's why zippers are forgiving. They can be reopened and reclosed. They realign themselves. They allow correction without consequence. This forgiveness builds trust. Over time, the zipper became invisible. You don't think about closing your jacket. You don't check each tooth. You trust the mechanism completely. That trust is earned, not assumed. Here is the clear moment of realization. The zipper works because it removes responsibility from the user. Once you start the motion, the system guarantees the result. Invisible design often succeeds by shifting effort away from the human and into the object. The zipper does this elegantly. It transforms a complex mechanical task into a single gesture. When it works, you don't notice the engineering. You notice the absence of worry, the quiet confidence that something is closed, sealed, finished. And that confidence, so subtle it rarely registers, is why the zipper still exists exactly as it does.